Okay, let's take a quick review before we have our quiz. We're going to review polynomials and radicals. So the first few, we're just going to name the polynomial by term and degree. So we have our largest exponent is a 2, so that's a quadratic. And we have 1, 2, 3 terms, so it is a trinomial. Here we have our largest degree is a 3, so that is a cubic, and we have 2 terms, so that is a binomial. Remember, nomial means terms. Here we have a single monomial, and our degree is a 3, so that's cubic because of the 3, and monomial because of 1 term. Remember, add and subtract, separate terms. So here we have 1, 2, 3 terms, so it is a trinomial. And we don't have a specific name with a degree of 4. Oh, no, actually we do. I was thinking 4 terms. So this is a quartic trinomial. Here we have a binomial. But be careful with this degree. I also, because I have another factor that's a variable, I have to include its exponent. So you have to combine those. And we say this is a binomial with a degree of 5. So don't call it a quintic when you're combining, just a degree of 5 is fine. Here we have 2 terms. We have a linear exponent here, an exponent of 1. So we call that a linear. It would make a line if we graphed it, binomial, because it has 2 terms. We have a quadratic because their exponent is 2, and it is a binomial. Here we have 2 terms. Here's 1 term and 2 terms. Oh, no, and 3. 3 terms here. So that's a trinomial. We have a degree here of 4. This would have a degree of 2, and this term has a degree of 0, but the whole polynomial we'll say has a degree of 4. Okay, now let's look at things that are not polynomials. So remember, you cannot have a variable as a radicand, so that is not a polynomial. This x is on the outside, that's fine. Here we have a negative exponent on the variable, and we know we can't have it. However, if we were to simplify it, now that we've learned our power rules, we really would flip it to the numerator and it becomes a positive. So that is a polynomial. However, this one is not a polynomial because I do have that actual negative exponent. We have to have a whole number exponent. This is not a polynomial because your variable's in the denominator. This one is okay. Here we have a variable that has an exponent that is not a whole number, so that is not a polynomial. But be careful here. Remember, you always simplify before you classify. 4 over 2 is really 2, so this is a polynomial. So this is not a polynomial. This expression is not a polynomial, and this expression is not. So these other ones remaining, these are polynomials. Okay, we're going to write and combine. So we have this trinomial, and it's subtracted from this trinomial. So in order to subtract from, we must write this one down first. And yes, you do need to bring your parentheses with you. Subtract means subtract. And now we put the first trinomial. Now, when I do this, I like to distribute what's out front. So this is like an understood positive one, which just gives you the exact terms that we have here. However, on this one, it's subtract. This is like a -1. So when I distribute the -1, it turns all of these terms in this trinomial to their opposite sign because we're subtracting. And now we can just combine. So I'm going to combine my quadratic terms. That gives me negative 10x squared. My linear terms, this gives me plus 14x, and then my constants, negative 1 and negative 2, that's going to give me negative 3. So I have a quadratic trinomial. Now we're going to determine the perimeter and the area of this rectangle. So let's add up all the sides. So I have 2 widths and 2 lengths. So actually I'm just going to double, this, and that's going to give me 4x squared plus 12. And then when I double this gives me 6x squared minus 16. And now I'm going to combine my quadratic terms and get 10x squared. And then my constants, I get minus 4. Notice I have no linear term, that's fine. So that is perimeter. Now let's do area, which is the length and the width multiplied. So yes, we need parentheses. So we have 3x squared minus 8 times the width of 2x squared plus 6. Now we are going to distribute the first term to this first term. We get 6x to the fourth. When we multiply like powers, you add exponents. And then we're going to multiply this first term to this second term. That is going to be plus 18x squared. So I have finished distributing 3x squared. Now let's move on to negative 8. That's going to give me negative 16x squared. And then I have a negative 48. So I have 6x to the fourth. I have a quartic term. I'm going to combine these quadratic terms. And then I have my constant of minus 48. Okay, let's simplify these. We have the square root of 28x to the fourth, y to the third. I'm going to break this down. So our perfect square is 4. 4 times 7. We can break down x to the fourth into perfect squares. And then y to the third has 1 perfect square embedded in it. I want to take the square root of 4, which is 2. I want to take the square root of x squared, which is x. I want to take the square root of another x squared, which is another times x, so that's 2 x's. And then I'm going to take the square root of y squared, which is y, leaving me with a radicand of 7y. Here we have division. Remember, we can't have a radical in the denominator. And once I rewrite this, I can see that actually in the denominator, that's a perfect square. So I don't have a radical anymore. We're going to break down 12 into 4 times 3. I take the square root of 4, which is 2, roots of 3 over 4. We're almost finished, but these two outside numbers, my coefficients, can simplify into 1/2. So I have the square root of 1 times radical 3 over 2. You do not have to put the 1 out here. Here, when I break this down, neither one of these are a perfect square. I can't leave a radical. 3 doesn't bite into 7, so I have to rationalize them, which means I have to multiply the top and the bottom by the square root of 3. And so I get the square root of 21 over the square root of 9. And then I can take the square root of 9 now, which is 3. And then 21 cannot be simplified anymore. And don't be tempted to divide this 3 into this radical 21. They're two different numbers. You are finished.